Let's create a Python code that classifies numbers as prime and not prime. We'll start off by creating a function called isPrime where we'll check if our number is truly prime, and we'll make our argument x. So let's start off by getting one thing out of the way. If x is less than or equal to 1, we know it can't be prime. The smallest prime number is 2, so therefore we can eliminate and call everything else false. We will then start a loop for I in range. Our range will be from 2 to int, which is integer of x to the square root times 0.5 plus 1. Now, what this is it is a list from 2 to the biggest possible factor of a number. We know that a square root times a square root makes up the number, and for any other factor greater than it, there has to be a factor less than it. So, by taking the square root with n times 0.5, which in Python is square root, this gives us the square root function which we proved we needed. The int you see though rounds a number down. So what this means is that if we were to have the square root of 26, it would become the square root of 26 rounded down, which is 5. This opens up the possibility for us to lose a potential factor, which is why at the end we do a plus 1. Now, until we get to larger numbers, this probably won't be the case, but it is still very important to have this just in case this is what happens. Now that we have a list of factors we can test, we will actually be testing them. So we will say if x divided by any of our factors I is 0, meaning there is no remainder and it divided evenly, we can return false, meaning it is not a prime number and it is a factor. If no divisors are found, return true, indicating that n is a prime number. We've classified numbers as prime. Now we can create a function that shows us factors of a number. So we'll create a function called listFactors, still use x as our argument. We will create an open string called factors. This is where we'll put our list of factors and test them. We'll create a loop for I in range from 1 to x plus 1. This will iterate through a range from 1 to x. Here, afterwards, we will say if x divided by any number in this loop has no remainder and it divides evenly, we know it's a factor. We will then append this value or add it back to our factors list. After looping through this over and over again, we will return factors, giving us our new class. We will now create a function that uses our past function of isPrime to classify and print statements. We will say that in the first part, if the given number is a prime number using the isPrime check, we can print a message saying so. Here we do print f. This number is a prime number. Make sure you put num inside the curly brackets. Once we have completed that, we now need to create an else statement. Once we have accomplished that, we now need to create an else statement in case our number is not prime. So we can say else, and then we can print a statement identical to the one on line 19, just saying is not a prime number. Make sure to use the f first, then print your statement. Then we can also list the factors. So we will do print in parentheses f factors of our number, and then in a curly bracket we can say num to print to the user num. And then we can use the listFactors function from above to print the list of factors for the number. Great, we have completed this function. Now we can move on to the part where the user actually gives us their input. So we can start a variable for our thing. We can call it number to classify. I am going to call it the number to check. And we are going to set this equal to the int of the input, and we will ask the user to enter a number. Make sure you have the int, as this is what creates the string into an integer for our thing. Now we can put this into the classify factor, and we can put the number to check as this. Now we can test to make sure it works. You can try numbers that are prime, try any number, and it'll work. If this helped, please consider subscribing, and thank you for watching another episode on the Tech and Math Hub.